Okay, this video shows you how to do multiple regression, and then we'll do one more video to show you how you do hypothesis testing for multiple regression. Multiple regression is when we have more than one independent variable. So in this case, we're looking at a whole bunch of variables and their impact on games won. You can't do that using scatter plots because this is a more than two-dimensional problem, math problem. So you're going to have to use this regression. And I'm going to go grab my y's first, including the label, and then my independent variables, my x's. And notice I got to grab all these at once, so they have to be all attached. You can't have the data in non-contiguous. They have to be attached. So I grab the data, I have labels, and I say okay. Now you get this big analysis done really fast. It's fantastic that it's there that fast. So let's look at some things. One thing we can look at is R squared and adjusted R squared. Let's just do them one at a time. We'll look at R squared. Actually, the first thing we'll look at when we do hypothesis testing, we'll go over this again. But the first thing you want to look at is this number. And you want that number to be greater than or less than 0.05. If that's true, then you know that at least one of your slopes, one of your coefficients are statistically different than 0. If that's greater than 0.05, you should just stop because you don't have a good model at all. The next thing you can look at is R squared. The R squared tells you how good, what the amount of variability that's accounted for in your model. And you can see out of 100%, almost 78% is accounted for in our model. So it's a really good model. It's useful. The third thing you should look at is all of these p-values. And these p-values tell you which of these are the most important. And I'm going to sort these. I'm going to sort, and notice I did not grab the intercept. Don't ever look at the intercept's p-value. Just look at the, and I'm going to sort them, and I'm going to sort them based on this 0.951. It's kind of silly, but it's the p-value column, and I'm going to do it from small to biggest. Because the smaller the p-value, the more important this is. So right now, that is the most important measure. That's the next important measure. Anything under 0.05 is real important. So I would say, and that's under 0.1, so these are probably your most important two. And maybe this one, but the rest of these are probably not that important. So that one's definitely important. That one's borderline important. That one's borderline important. The same thing on these three. So that one's very important and sort of important, not important. So that tells you which ones are most important. After that, we can focus on the coefficients. The coefficients are the slopes. And what we're looking at is that if I'm trying to estimate wins, I need to have an estimate of each of these, and the estimates get multiplied by the individual coefficients. So I'm going to hide some columns, and then I'm going to put over here if x equals, and for the intercept I'm going to put 1. So these are I'm going to guess on what these or I'm going to put some numbers in here so I can multiply this times this plus this times this plus this times this. Essentially, I'm going to craft a team. I'm going to see what that does to my wins. I'm going to calculate a formula right there. So let's do that. Let's say that I've got a quarterback who throws for 2,500 yards. And I have a defense that can keep the other team, and they're going to rush for 1,900 yards. And I've got a running back who's going to run for 900 yards. And my defense is going to limit them from passing to 1,700. My penalty yards per year, I'm going to say it's going to be about 900. My field goal percentage is 50%. My turnover differential, it'll be about the same. And my punt yard average is 45 yards. So with all those estimates, the number of wins that I expect to get, I'm going to use a sum product formula because that's the easiest one to do, sum product. And what I'm going to do is take these multiplied by these. So what Excel does when you use the sum product, it takes this pair, I need to fix this. This needs to be the same dimension like that. So it takes this times this plus this times this all the way down to this times this. So that's how many wins I expect to get in this season, which isn't very good. It's kind of right in the middle based on this. So what if I could improve my defense? What if I think that I could get a defense and maybe draft or hire someone who is going to help my run a lot better, and I can drop this to maybe 1,300 yards? Well, look at that. That's worth 2 wins. I've increased my wins. I'm getting close to making the playoffs if I can find someone or either a coach or a player that can reduce my rushing yards allowed from whatever it was to 1,300. So you can put all of this information in here, and so these tell you the impact of a unit change of these on wins. So that's how you build a multiple regression model, and that's how you use it to predict. I'm going to go ahead and do my hypothesis testing in this one. So here are my steps. We've already done this. The null hypothesis, it's real similar to this one that we did earlier. The only thing is that we have multiple slopes. So we have slope 1 equals slope 2 equals slope 3 equals ... all the way to slope 8. We have 8 of these things. Slope 8. And we assume that they're all the same and they're all equal to 0. And then this one says at least one is not 0. Set alpha to 0.05. My F statistic, where's the F statistic come from? Right here. Let me go back and unhide these. My p-value is equal to that, and that p-value, which is a very small number, is less than that, so we reject the null hypothesis. So we can say at least one slope is not 0. The regression model is useful. So that's doing the hypothesis testing. After you do that, then you can go start looking at which ones are the most important.